Hi, my name is James, and this is the second video in Cardano Starter Kit number 2. In the first video, I shared some of my ideas about how thinking a little bit more like a teacher might help you prepare for conversations where you talk about problems and projects that can be built on Cardano. In this video, I want to dive into the Marlowe Playground, and I want to ask this question: how can this playground help us talk about Cardano? Even if you're not a developer, the Marlowe Playground is designed to allow you to tinker and learn more about what Cardano can do. And I think that if you spend a little bit of time playing with these tools, that too can help you prepare for conversations about what Cardano is, what kind of tools are being built on it, and what it can do. So we're going to look at these questions today. What can we do as non-developers looking at the playground? We're going to look at each of the 5 contracts that comprise Marlowe. And we're going to ask, hey, how would I describe each of these in a conversation? Then we're going to dive a little deeper into 2 of them, the If and the Assert contracts. And we're going to look at how they behave differently in the Marlowe simulator. Then I'm going to share some ideas for further reading. This should be really fun. Let's get going. Let's start by taking a look at this document that was just published this week. This is the Developer's Guide to Marlowe, and I'm going to link to it in the documentation that accompanies this starter kit. Now, I mentioned in the first video that finding high-quality content, reading it, and then taking the time to really think about the implications is a great way to prepare for conversations with people who are new to Cardano. Here's an example of that. I'm going to skip to the end. And there's a paragraph right here that really caught my attention. This says, right, once you're happy with a contract in Blockly, after you play with it, after you go into this sandbox, you can simulate it. The simulator lets users walk through the contract without deploying it. That's the really important part, to gather data on its actions, its evolution, and how it deploys. It's hard to build a developer environment. It's also risky business to publish, to deploy a smart contract. Because if you do something wrong, somebody's going to figure it out and take advantage of you. So what this allows us to do is, with minimal effort, just come in and play around, get to know what Marlowe contracts can do. If you're looking for ways to get better at talking about Cardano, and in particular right here Marlowe, but this also applies to other tools that are coming out. If you want to be better at talking about them, spending some time exploring on your own is a really good way to do that. And that's what we're going to do today. I want to jump in to the Marlowe Playground. I want to look at some contracts and let's simulate them. Let's see what happens there. And after we do that with some of the examples, then we're going to take a look at the 5 contracts and design a few of our own to see how they work. When you first navigate to the Marlowe Playground, here's what you'll see. There's an overview of Marlowe and the playground, and this diagram that shows how the different programming languages can interact as you're using the playground. There's a link to a tutorial, so if you want to go deeper, you can go through these notes. They're great, and again, these fit that definition of high quality content. It's impossible to read through this tutorial without having some big ideas. Also, if you've never looked at the Blockly editor before, I also gave an overview of it in Cardano Starter Kit number 1. And in that video, I made a faulty smart contract that has 2 people making a bet with each other, but it doesn't really handle what happens when 2 people disagree. So what I want to do here is open up an example, this link at the top of the page. When I do that, I see that there's 4 demo files so far. Each of these defines a financial instrument, a kind of financial contract. And so in addition to learning about code, the Marlowe Playground gives you a starting place to develop some more financial literacy. If you've never heard of escrow or swaps before, this gives you an initial definition of what these contracts do. And if you want to go deeper, you can search any of these terms online to learn more about them. For now, I want to look at this escrow contract because actually the solution to the problem I posed in starter kit number 1 is here when we have this idea of a third party regulating disagreement if there's two parties in a transaction and they have the chance to maybe disagree. That's what our bad bet contract was all about in Cardano starter kit number 1. So let's look at the solution. This one's a little bit different than what I shared because only Alice is depositing to the contract. All right. But once Alice makes a deposit, then both Alice and Bob are going to make a choice, 0 or 1, about what happened. If they agree on what happened, the person that's supposed to get paid will get paid. But if they disagree, this third party named Carol will choose who ought to get paid. You can look closely at this code on your own. I really want to check out the simulator today. Let's go take a look. So I click on Send to Simulator. I have a few tabs here along the bottom, and I can see what the code looks like in pure Marlowe. And if you scroll through this code, after scrolling through Blockly, you can find how, all the written code here aligns with the Blockly code in that editor. If I make a change here, it'll be reflected in Blockly and vice versa. Now, a few things the Marlowe Playground allows us to do. First of all, we can simulate the contract. Let's do that. Start the simulation. Let's pull this up so we can see the state of the contract. Alice has only one choice, to deposit 450 ADA. And then she's going to make a choice. Let's say she chooses 0. Let's say Bob agrees. And what does that result in? Okay. I can go over here to logs if I want to see the final results. Alice deposits. Alice chooses 0. Bob chooses 0. And that means Bob gets paid. Now let's try it again. This time, let's have Alice deposit. Let's have Alice choose 1. Let's have Bob choose 1. And what happens this time? If they both choose 1, then Alice gets paid. Good. What happens if they disagree? What if Alice says I should get paid? What if Bob says I should get paid? Now the contract doesn't close. Now Carol has to choose who's going to get paid. Let's say she says 1. All right, then we can see Alice gets paid. Now, here's another really important thing that comes up when we play with the Marlowe Playground. Well, who's Carol? How does she know who's supposed to get paid? This is a really big, important question. And there's a lot of work being done around something called oracle pools. You might hear this word, oracle. Oracles tell blockchains what's happening. And we just saw in the October Cardano developer update that oracle information is on the horizon. Simon Thompson demonstrated for the community yesterday how you can pull in Kraken data, for example, from the Kraken exchange about the current value of ADA. And that's just an initial drop in a very big bucket. There's a lot of really important work to do around telling blockchains what's actually happening out in the real world. Why am I sharing this with you right now? Well, I hope that when you look at this simulator, you think of questions like this. And if you have a big question like, who the heck is Carol and how does she know what's going on? That's exactly what you should be asking. And that leads us to talk about how important oracle pools are. Going much deeper into that question is beyond the scope of this starter kit, but just know that in the weeks and months to come, we're going to learn a lot more about the different work that's being done around oracle pools. And by looking at this for yourself, hopefully you can get a little bit better at talking about some of the hard problems that people are working really hard to solve on the blockchain right now. Oracle pools being one example, identity being another. How does the blockchain know that Alice is who she says she is and Bob is who he says he is, right? So identity is another problem that's being worked on right now. And there's a lot more documentation. IOHK and Emergo are publishing information and new tools. And again, over the next few months and weeks, we're going to have a chance to get our hands on these tools and start to use them. I just want you to be ready for these sorts of conversations. Now, there's one more thing I want to show you here with this built-in example. And this is the static analysis tab. I can analyze a contract. Okay. And what this does, just long story short, because Cardano is built on Haskell, we have the ability to prove that contracts work under all scenarios. If I look at the reachability, look, it counts through. It shows me the different possibilities that might happen. And this shows me that the simulator can't find any analysis that's not reachable. Now, fully understanding that, you're going to have to take a look at the tutorial, and we're all going to keep learning together. But I just want to show you today what's possible here. And now that we've gone over these basics, let's take a look at putting together some contracts for ourselves. In the first part of this starter kit, I mentioned that my domain of expertise is education. And I did that on purpose because Marlowe also has a specific domain of expertise. In fact, Marlowe is called a domain-specific language. It's not a computer programming language that's built to do everything. It's just good. It's really good at a small handful of things. What's Marlowe's domain of expertise? Financial contracts. So when you look at these examples, like I showed you a moment ago, you're going to see some particular financial instruments. But even when we go just to program, I can either press New Project up here or Start Coding down here, and I can go into the Blockly editor. Even when I'm just playing around with an empty workspace, the number of things I can do with Marlowe is pretty strictly limited. That's what makes it a domain-specific language. What I want to show you right now are the 5 basic contracts of Marlowe. Here they are. If you're looking closely, you'll see there's actually 6 because we have close here. So we'll talk about that one too. But there's 5 Marlowe contracts that accept parameters. And so parameters are just the different values that we can add to structured code to make it behave in certain ways. Okay. And if you're wondering what sorts of parameters we can add, that's where Blockly really shines. So for example, a payee can only be a party or an account. And if I try to put these elsewhere, it doesn't work, okay? So which parameters go where is illustrated by the types of blocks that we're able to click in. And the same goes, so for example, can I put a token in the payee? No, I can't. Token would be the type of currency. And one thing that's coming out on Cardano is the ability to create your own native tokens that come with all of the power of ADA. This is a really big story that a lot of us are going to be digging into over the next few months, okay? But for now, just know that The type of currency, the type of token is itself a parameter. We're going to have a good time playing with this block sometime soon. But again, today I just want to talk about these 5 contracts. Each of them has its own set of parameters, and each of them does different things. When, pay, if, let, and assert. What do they each do? And if I think about what each of these does, how does that help me talk about Cardano with somebody who might have less experience? How does it help me talk about what Marlowe is and what it can do? Well, you can read the overview in the tutorial, or you can listen to me try to say it my way right now, right? So a when contract waits for something to happen, and then when that thing happens, it keeps going. So for example, wait for an action. And once a deposit happens, then do something. Continue. Pay does exactly what it sounds like. Pay somebody. Who can you pay? You can pay into an account, or you can pay a party, which is either represented by some public key or some person's role in this contract. After it pays, it keeps going. The if contract performs a test. What does it test? It tests on an observation. So I see the word observation here. I head over here to look at the types of observations that are available. Each of these observations has parameters. For example, this is less than or equal to that. And each of these other observation blocks has different sorts of 1 or 2 blocks that we can put in. All right. If the observation is true, then one thing happens. Otherwise, another thing happens. What sorts of things can happen? Well, you could figure this out for yourself by looking at what can clip in here, but I'll just show you. Contracts can happen. If some observation is true, let's pay somebody. If some observation is true, let's wait for something to happen. If some observation is true, can we just deposit? No, we can't. The actions don't fit in there. And this makes logical sense, right? Where an if statement, an if contract tells the computer to execute on something if some observation is met. But the computer doesn't execute deposits, so we can't put a deposit block there. Similarly, the computer's not going to be making a choice, so I can't put a choice action there. What I can put are contract blocks in the if and else. So now you can see that from these 5 basic building blocks, we're going to combine them in whatever ways are necessary to accomplish what we want to accomplish. The let block is also really interesting, and this is kind of similar to how the if observation is going to be able to pull in Oracle data someday soon. The let box can store information from the outside world. So, for example, the price of commodities is volatile. The price of oil changes every day. The price of ADA changes every day. How are we supposed to build reliable contracts between 2 or more parties if the value of some asset is changing every day? Well, the let block allows us to say, well, suppose the value of something, the price of oil, the price of ADA, the number of widgets in, this place, whatever. Let's agree that on the day we implement this contract, we're agreeing to some value. Oracles can provide this information. Oracles are going to be able to provide information upon which observations can be made. Oracles are going to be able to provide price data for different commodities. So I'm really excited to play with these blocks a lot more once we get hands-on access to some of the Oracle functionality that's coming out soon. But for now, I just want you to know what these blocks can do. so you can start thinking about how to talk about them. Finally, assert. Check that something. I'm assuming that's an observation again, yes? Yes, good. Check that something holds, and then keep going. Doesn't that sound a bit like the if statement? If you think so, then you're exactly right. So in the next part of this video, I just want to compare two contracts. One that uses an if contract and another that uses an assert. And then we're going to look at how those behave differently in the simulator. For now, we just went through these 5 contract blocks. Okay, I should probably touch on close real quickly. Close just says if you don't want to continue, right? If you get to the end of something. So for example, after you pay somebody, if that's the end of the contract, that's fine. You can close it. If you want to keep going, you can do that too. All right. But close is used as an end point for any of these contract blocks. The last thing I'll urge you to do before I move on to this if versus assert conversation is think about how you'll talk about these 5 contracts. Are there stories that you could tell about each of them? Are you talking to somebody, a friend or a family member, who understands the volatility of certain markets and would be interested in knowing how a let block works? Are you talking to somebody who just wants to know basically what a smart contract can do? Are you talking to somebody who might be really curious to learn more about Oracle pools? It really depends on the audience, what your messaging is. In the weeks to come, we'll look at more examples of how to put these things together. But I hope you spend some time trying to figure out, hey, what happens if I combine an if with 2 different payment blocks? What happens if I pay somebody a little bit and then wait for something else to happen? And so on and so forth. So go ahead and play with those things. In the next part of this video, we will make a contract with an if statement and another one with an assert, and we'll see how each of those work. What I'd like to do now is build a very simple example of something resembling a crowdfunding project, but we're only going to have 2 friends funding one other friend, all right? And there's a lot of stuff I'm going to skip here. Anytime we're talking about something for the first time, I definitely have a tendency to try to overshare and cover a lot of different bases, but I want to keep this simple, so I'm not going to cover everything. Although I might drop in a few of my favorite coming attractions as we go through this, okay? What I'd like to do is have 2 friends deposit some money into a contract that a third friend gets to do something with. And then we're going to look at how if and assert function in similar but different roles and each having different outcomes when we want to talk about, all right, how much money is there actually in this contract? Let's get started and let's see if this makes sense. So, anytime I'm waiting for somebody to put some money into a contract, I'm going to use a when block. When just waits for somebody to do something. It waits for some real world input to happen so that the contract can keep going on the computer. What are we waiting for? We're waiting for an action. We're waiting for this outside world thing called a deposit. And once that deposit happens, then we're going to wait for somebody else to make another deposit. Now, if this deposit never happens, we have to make sure the contract times out. All Marlowe code only works if it knows that it's not going to go on indefinitely. Okay, that's built into Marlowe. We have to tell when a contract is going to time out. So remember, this block was first. If this first thing never happens after 50 slots, let's close. Then I'm going to make this number higher because after the first person deposits, now the second person has a chance to deposit, and we'll give them up to 50 as well. Now, what really should happen right here where I just put this close block is if the first person deposits and the second person never does, this person right here should get their money back. I'm not going to spend the time to show you that right now, but as an extension, that's kind of a detail that you could choose to fill in. And again, go back to starter kit number 1 if you want to take a look at some open problems that I left. This is similar to that. What's important to me is that after both people deposit, then we continue by paying someone. And after we make that payment, then the contract is over. All right? One person deposits, another deposits, a third person gets paid. Let's define who these people are. Well, deposits have to be made by somebody, some party. And Marlowe uses the word role for that. I'm just going to call this friend 1. And then we can have somebody called friend 2. And the payee is somebody named friend 3. Wait a minute, but that doesn't work. You see the word payee? There it is right there. Okay, and a party block goes inside the payee block. And now everything clicks together. So again, the blocks are always going to tell you if you're on the right track. What are these friends sharing? They're sharing ADA, of course. And I can't wait to play with this token block. We're going to have a lot of fun figuring out what it means to build our own tokens sometime soon. But not today. All right, we're going to get to that. All right, let's see. Everybody's getting ADA. How much ADA are each of these people? That's a value. Let's say that each friend is putting 500 ADA into the contract. And as for where they're putting that money, let's just put it into a shared transaction. Okay, I'm just going to call this shared for now. There's a lot more to say about where we could hold these funds in the interim, but I'm just keeping it super simple for now. We'll come back to that another time. All right. So it's going to be friend 1 deposits 500 to some shared transaction. Friend 2 does the same. And friend 3 is going to get the money from there. How much money is friend 3 going to get? Well, whatever was put in there. Let's let the computer do the math by using this available currency block. Available currency. What kind of currency? ADA. And if you're not sure what kind of block goes there, just try things until something clicks in. What kind of currency? ADA. From where? This shared transaction right here. I'll save that. Now let's go just make sure this works. Before we check anything about the amounts of money in this shared transaction, let's just make sure this works. Go over to the simulator. I've got the logs tab open because this shows me step by step what's happening. Let's start the simulation. Let's show friend 1 depositing 500 ADA. Then we click this button. Friend 2 can do the same. And after that's done, the contract is over. You see, once friend 2 deposits, the computer doesn't have to wait for anything else. So friend 3 gets those funds. Really quickly, let's head back. What if friend 1 had put 1,000 in? Now friend 3 should get 1,000 plus 500. Let's see. Friend 1 puts 1,000. Friend 2 puts 500. And sure enough, friend 3 gets all of whatever's there. Cool. Well, now what if friend 3 needs a certain amount of money in order for the whole thing to be worth it, right? Think about a crowdfunding campaign where somebody's trying to raise X dollars to complete a certain project. And if they don't have that much, they're not going to start that project, right? We want to check that friend 3 is getting however much they need, whatever that is. Let's figure out how to do that. let's suppose that friend 3 needs 1,000 ADA. I'm going to put this pay piece aside for just a moment. We do want to pay friend 3, but we only want to pay friend 3 if some observation is true. What's the observation? Well, it's that the amount of money in this shared transaction is at least the 1,000 ADA that friend 3 needs. If this is looking for an observation block, let's go find an observation block. And what am I trying to do? A certain value is greater than or equal to 1,000. So value has to be greater than or equal to 1,000. What value? It's this value right here, isn't it? It's the amount of ADA in this shared role, in this shared transaction. That works. Cool. All right. So if the available ADA that's been dropped into this shared transaction is at least 1,000, then let's pay friend 3. Otherwise, we'll do this the right way this time. Otherwise, let's just pay both people back. Okay? And you know what? I'm going to use a lot of the same information as up here. So who? Friend 1. Oh, I remember. Right. That needs to be a payee, though. So the party is going to be friend 1. And the amount is going to be, well, I'm making this a little simple right here. We're just going to hard code this for now. In reality, we should do a better job keeping track of who deposits what and where. But because that's beyond the scope of this video, I don't want this to get too long. I'm going to keep this simple for the moment, okay? And actually, I can reuse this block. So I'm going to delete this one. I'm going to click this one, and I'm going to copy it and put it here and have friend 2 getting their money back as well. And then once again, we'll close. Now, this is not best practice. Anytime we try to keep things simple, we ignore the reality of what we really have to do. But for a proof of concept, my goal is just to show you how an if statement works. Let's first of all just see if this works. Let's send this to the simulator, start it, and what we should see is no difference from last time. Sure enough. But what if I went back to Blockly and we said that friend 1 was only going to put 450 in? And this is why this is bad code. I shouldn't have to type this number twice. But for now, I'm just remembering that friend 1's amount goes in both of those spots. Let's just take a look at this. Send that to the simulator. Start. Friend 1 deposits. Friend 2 deposits. And then what happens to the money? It's not enough. It just goes back to friend 2 and friend 1. There's a few things missing here. I already mentioned that I shouldn't have to type this number twice. There should be a better way of storing this value somewhere. We'll look at that someday soon. Also, there's no message here about why this went wrong. So we'll start talking about how to build in kind of that messaging and logic sometime soon as well. For now, what you can see is that the if statement stopped friend 3 from getting the funds because they didn't add up to 1,000. What if friend 1 was feeling super generous and had 1,500? And then down here, I change it to 1,500. Whoops. And we run that. Okay, friend 1 puts in that much. Friend 2 is steady. Friend 3 gets the sum. All right, so far so good. So that's really how the if statement works, right? It says, look, after some things happen, let's check some condition. If that condition is true, do this. Otherwise, do that. Cool. So that's one way to approach this problem of checking. But like I said, we were going to compare. I'm actually going to save this for just a minute. We were going to compare if to assert. Because at the surface level, assert feels like it should do something similar. I can grab the assert contract and put it here. And then I can say, check that, does this still work? Sure does. Check that the amount in the shared transaction is greater than or equal to 1,000. And then continue. Okay? It's like an if statement in that it's checking something is true before it continues. But there's no else here. So what the heck is going on with assert? All right, first of all, let's just make sure this code still works. Yeah, I can leave that 1500 for now. All right, so there's going to be too much ADA, which should be fine. Yeah, sure enough. Okay, so we haven't changed the functionality of this contract. But what if I go back and I change this number to a 400 now? Friend 1 only puts 400 in, which is not enough. Send that to the simulator. Start the simulation. Friend 1 puts in 400. Friend 2 puts in 500. And then check it out. Even though that assertion was there, friend 3 still gets paid. Well, I guess that's nice that that's flexible. But check it out. When I go over here to the state, I see that an assertion in the contract did not hold. I get this message. Okay, let's see when that shows up. Let's see. So I'm in the current state. So far, so good. And then we see transaction assertion failed. The assertion failed, but the contract didn't. Who's that good for? Well, when we come to analyzing contracts and looking at warnings or errors, this is really where this is going to come in. Now, I've been playing with the Marlowe Playground today, and for some reason, oh, there it goes. Okay, good. This wasn't working earlier, but it looks like they fixed it since then. Nice job. Okay. When I go to static analysis, how cool is this? There's a warning issued. Transaction assertion failed, right? It doesn't say that the whole thing is off. All it's telling me is that when I analyze this contract before actually deploying it, there's a problem here. And this is a really, really powerful feature. And this is really what the assertion contract is for. It's less for the eventual real-world execution of a contract and more for testing it to make sure that it's behaving the way you want it to. And you can see right here that I get the warning that only came from the fact that I put that assertion in there in the first place. Okay? Isn't that cool? And it shows me the list of what it calls offending transactions. What happens? Does this reachability button work? Okay. So yeah, it passed the reachability test, but it found my assertion warning. Very cool. All right. So this video is already getting long and there's plenty of stuff that we haven't covered. So I guess we're just going to have to keep doing this, right? I really hope that this video has been helpful to you. I really hope that you're troubled by the way I used this close block right here. And you can maybe come in here and help make sure that friend 1 gets their money back if friend 2 doesn't show up. And most of all, I hope that by taking this time to look at something technical, you're having more ideas for what you want to tell your friends and your family about Cardano. What's Marlowe? What can it do? Can I play with it too? And the answer to that last question is absolutely. Let's go build something. So until next time, please check out the documents if you're looking for more information or more steps that you can take. And join me on GitHub, on Discord to talk about this starter kit. I'm really excited to be building with everybody. Let's go. All right, be well.